going to move away from right triangles now and start dealing with oblique triangles, which are triangles that are not right. Okay, so any triangle that's not a right triangle is generally classified as an oblique triangle. And there's two laws that we can use to solve these triangles, to find every part of them. The first one is the law of sines. And if you remember, in right triangles, we just needed two measurements, so either an angle and a side or two sides to find every other measurement. In oblique triangles, you need to have three things. Okay, the law of sines states that the ratio of a side and the sine so the ratio of a side and the sine of the opposite angle is constant. So that means if I take a side, like side A, and put it in a fraction with the sine of angle A, which is the angle across from it, that's going to be the same for every combination that's set up that way. So C over the sine of C equals B over the sine of B. Okay, or we can flip-flop them. Okay, so it doesn't matter as long as they're all set up the same. This is the law of sines. Okay. Now, there's certain situations that we can use for this, and there's certain ones that we can't use for this. Okay, so let's just look and see if we can set up a proportion that would work. So if I've got side angle side, this is side angle side, I could say C over, or sorry, the sine of C over C, but I don't know what C is, so I can't use that. I have B, but I don't have the angle B. I have A, but I don't have angle A. So I can't use the law of sines when I have side angle side. Okay, so this does not work with the law of sines. How about this one? I can do the sine of C over C, and that should equal the sine of B over B. So if I'm given two angles and a side, so angle, angle, side, or we could do side, angle, angle, that works because if I'm given C and angle C, I can set up a ratio. Then I just need one other piece from the other ratio. So this one will work. How about this? B over B, I don't know B, so I don't have a fraction there. C, I don't have the other C. A, I don't have the other A. So this doesn't work. Angle, side, angle does not work. Okay. What if I have A over A? All right, well, that'll give me a fraction. Okay, if I have those two things. B, I'll be able to find the other B. Okay, so this will work. Except, yeah, this will work. Okay, because once I know A and B, I can find C, and knowing angle C will allow me to find C. Okay, this is the angle side-side. So for a reason which I think you'll see, we're going to call it side-side angle. This is actually a specific case where you could have more than one answer. Okay, so this is a case where you could have one answer, no answers, or multiple answers. So let me give you an example here. We could have angle side-side in this situation where this other side actually doesn't work, doesn't connect. Okay, because if this is a set angle and these are set lengths, I could have this situation. So this would be like a no solution situation. And I'll show you what this looks like in some examples. So I could have one solution, I could have no solution, or I could have this case where this angle's fixed, this side is fixed, and this side is fixed. But there's going to be two angles that I could use with this given length A, either here or here. Okay, so I could have two answers from this case. So let's run through some examples using the law of sines, and we'll see somewhere we have the ambiguous case here. So this is angle, angle, side. So I can do this one because the sine of 50 can go over 20, and that should equal the sine of 35 over whatever this is. So we'll call this B. We need to find C and C. Okay, so B. Bring my calculator here. All right, so let's make sure we're in degrees since we're dealing with degrees. Then we do the sine of 50. Sine of 50. Okay, actually, let's just do the math because we're going to cross multiply here to find B. So it goes back to when you first learned to cross multiply. Multiply these, divide by that one. Okay, so sine of 35 times 20 divided by sine of 50. Okay, that's what B is. So B is 14.98, we'll call it. If this is 35 and that's 50, C is going to be whatever it takes to add up to 180. So this is 85, so this is going to be 95. Which means I can use the same ratio. Sine 50 over 20 equals sine 95 over C. So I do sine 95 times 20 divided by sine 50. So C would be 26.01. And now I've solved this triangle. I've found out every part of it, all the angles and all the sides. Next example. Here I don't have a picture, but I'm just going to draw one. Okay, A is 60. Side A is 9. Side C is 10. So this would be C. This would be B. This would be B. Okay, so I can do sine of 60 over 9 equals sine of C over 10. So cross multiply and divide. Sine of 60 times 10 divided by 9. So that means that the sine of C equals 0.96. Okay? Now this is angle side side, okay, which is our special case. So when we're figuring out what C is, I'm going to do the sine inverse. Okay, so sine inverse of what I'm given here. And I get 74 degrees, okay? So 74.21 degrees. Now, the other place where the sine of C would equal this would be 180 minus this. Okay, 180 minus my answer. I get 105.79. So here's how we're going to figure out if there's more than one triangle that we're dealing with. The angle I'm given is 60. If I take 60 and add it to 105, do I have enough left over for a third angle? Okay, because this would be like 165.79, and that would leave enough left over for an angle C to exist. Same thing if I add 60 here, because the three angles have to add up to 180. So I'm actually going to have two answers from this point on. So let's move this next one out of the way. So from here on, I have to treat it as though I have two different triangles I'm working with, because I'm going to have two answers. Because C could be 74.21. Okay, and with 60, that would leave 45.79 degrees for this last angle. Or I could be in this situation. I've got my 60. I've got my, let's see. Let's do the big one first. I've got my 105. I've got my 60. I've got 14.21. Okay, so this is still 9. This is my, oops, I kind of switched things here. Across from 60 is 9. Across from C, which is the angle I just found, so this one is 10. This one is 10, 9. And now I've got two situations that I've got to solve. So sine 60 over 9 equals sine 45.79 over B. And that would solve this triangle. Or I can have sine 60 over 9 equals sine 14.21 over B. So I'm going to have two solutions, two triangles that could have these properties in them. So let's solve for B in this one. 9 times sine of 45.79 divided by sine of 60, 7.45. And let's solve for the other B. So 9. Here, let's just bring up what I just typed in. Pretty much the same, except this changes to 14.21. So 2.55. Okay, so that's how you get two solutions. Okay, you take the one answer you get, you take 180 minus it, and that gives you another angle. If this angle can combine with this one and still leave some measurement over for the last angle, then you're going to have two answers. If this had been 130, okay, 130 with 60 would be 190, and that's more than 180. So then I would just have the one solution. Let's look at another example here. So I've got angle A is 110. Side A is 125. Side B is 200. Okay? So this again is angle, side, side. Okay, so if you spell that out, that should be a hint that it's a special case. So that's an easy way to remember it's a special case. All right, so the sine of 110 over 125 equals the sine of B over 200. So let's solve for the sine of B. Sine of 110 times 200 divided by 125. So you get that sine. So sine of B, okay, that's what the sine of B should be. Sine of B equals 1.50, okay? Problem with this is we know that the sine can never be bigger than 1, okay? Since the sine is opposite over hypotenuse, and the hypotenuse is always bigger. I'm always going to be taking something smaller divided by something bigger. Okay, when you take something small and divide it by something bigger, you get an answer that's less than 1. I can't have a sign that's bigger than 1. So this is no solution. Let's look at, we're not going to do this last one, but let's look at these things because these are things that you'll see, degrees and minutes. It's just like a clock. There are 60 minutes in 1 degree. So this is 2 and 45/60ths, which is 2.75. Okay, so really this is 2.75 degrees. And then you can do sine of that over 6.2 equals sine C over 5.8. And then go from there and solve it. Okay, I just want to show you the minutes thing because that'll come up. Okay, so that's how you do law of sines.